In this video, we will see how reorder point can be calculated given a desired fill rate. We'll consider two cases. In the first one, we will assume that demand during lead time it follows a discrete distribution, and in the second case, we will assume that the demand during lead time follows a continuous distribution. When we are talking about fill rate, we are interested in the number of back orders or the number of shortages. The number of units back ordered during an inventory cycle is in fact the maximum of the difference between the demand during lead time and the reorder point and zero. DL minus ROP in fact represents the number of extra units that we have at the end of a cycle, or the number of shortages that we have. So if demand during lead time is equal to ROP or less than ROP, then we will have no shortages. We'll have some extra units on hand at the end of the inventory cycle. But if demand during lead time is greater than reorder point, then we will have some shortages, and the size of these shortages is in fact the difference between the demand during lead time and the reorder point. This expression is a random variable because DL is a random variable. We will take expectation of this number, of this random variable, which will look like this. It is J minus ROP multiplied by probability of demand during lead time being equal to J. And we will take the summation of this expression for all J values that are greater than ROP. Here we need the distribution of the demand during lead time. Here PR of DL being equal to J. And of course we have a summation because the distribution is discrete. Then the following expression for the fill rate can be achieved. Fill rate for a given ROP and Q, the realized fill rate, is equal to this expression. In the numerator we can see the amount of back orders that should be accounted for in the present cycle. In fact, the number of back orders, we deduct the number of back orders that cannot be satisfied using the present inventory cycle from the total number of back orders to get the amount of back orders that should be accounted for in the present cycle. And then we divide it by the expected demand in a cycle. So it will give us the fraction of the customers who are not immediately satisfied in a inventory cycle. So if we subtract this value, this fraction from 1, we'll get the fill rate, which is the fraction of the customers who are immediately satisfied using the inventory on hand. And we can say that for a large Q, if the Q is large enough, then this expression, the second expression, is equal to 0, or can be approximated by 0. Not equal to 0, but it can be approximated by 0. So the fill rate as a function of ROP and Q can be approximated by this formula: 1 minus the expected number of back orders in an inventory cycle divided by Q, which is the expected demand during an inventory cycle. So having the order quantity and the target fill rate, we can numerically find the reorder point. So assume that we have a target fill rate denoted by FR, and we have Q, the order quantity. So we want to find an ROP which satisfies this equation. And what is this equation? It says that the fill rate, the realized fill rate for ROP and Q being at least equal to the desired fill rate.